The Hubble Space Telescope's journey has been nothing short of revolutionary, marking one of the most significant milestones in space exploration. Launched on April 24, 1990, aboard the Space Shuttle Discovery, Hubble became an indispensable tool for astronomers, profoundly altering our perception of the universe. Its ability to capture stunning, detailed images opened a new window to the cosmos. However, the telescope's path to success was not without its hurdles. Shortly after its deployment, NASA identified a major flaw in the primary mirror, which caused the images to appear blurry and out of focus. This defect was a severe setback for the mission, casting doubt on the telescope's potential. Despite this initial challenge, Hubble continued to operate, capturing images of both nearby planets and far-off galaxies, providing valuable data for the scientific community. The real breakthrough occurred in December 1993 when NASA sent a specialized team of astronauts on a high-stakes repair mission. Their objective was to install new instruments and make crucial adjustments to correct the mirror's flaw. The repair mission was a resounding success, and the improvements made to Hubble's optical system led to a dramatic enhancement in the quality of the images it captured. Since then, Hubble has continued to be a vital source of astronomical discoveries, revolutionizing our understanding of the universe with its newfound capabilities. The Hubble Space Telescope revolutionized our understanding of the universe by unveiling cosmic wonders that were previously hidden from view. It allowed astronomers to explore the farthest reaches of space, capturing light from distant galaxies and offering groundbreaking insights into the nature and structure of the cosmos. Among its many achievements is the iconic image of the Pillars of Creation, showcasing star formation within the Eagle Nebula. This breathtaking image, along with countless others, not only expanded scientific knowledge but also ignited public fascination with the mysteries of space, making the universe more accessible to people around the world. Despite being initially designed for a 15-year mission, Hubble has far exceeded expectations, continuing to operate successfully for more than 30 years. A series of servicing missions and technological upgrades have ensured that it remains at the cutting edge of astronomical research. Hubble's continued success set the stage for future advancements in space telescopes, including the development of the James Webb Space Telescope, which is poised to build on Hubble's remarkable legacy with even more sophisticated technology. Throughout its mission, Hubble has captured over 1.5 million observations of the universe. These observations have been instrumental in the production of thousands of scientific papers, cementing Hubble's reputation as one of the most productive scientific instruments ever built. Whether studying the planets in our own solar system or probing galaxies billions of light years away, Hubble has fundamentally transformed humanity's view of the universe, contributing immeasurably to our understanding of space. In the vast reaches of space, astronomers have identified a celestial structure that remarkably resembles a human hand. This formation, known as the Hand of God, offers a captivating view of the dramatic aftermath following a star's death. Captured by NASA's Nuclear Spectroscopic Telescope Array, NuSTAR, which specializes in detecting high-energy X-rays, this image provides scientists with a perspective that optical telescopes cannot reveal. The Hand of God is a pulsar-wind nebula formed from the remnants of a massive star that exploded in a supernova. At its core is a dense, rapidly spinning pulsar, named PSR B1509-58, which rotates 7 times per second. As it spins, the pulsar generates a powerful stream of particles that interact with surrounding magnetic fields, creating the distinctive hand-like appearance. The immense energy involved produces X-rays that NuSTAR detects. This hand-like shape is an example of pareidolia, a psychological effect where people see familiar shapes in random patterns. While it may appear to be a hand, it's important to remember that this is a natural formation shaped by intense cosmic forces. The fingers are high-energy particles ejected from the pulsar, while the palm is where these particles collide with nebular gas, causing it to glow in X-ray light. Interestingly, the Chandra X-ray Observatory previously observed the same structure at lower energy levels, and combining data from both NuSTAR and Chandra has provided a more detailed understanding of the processes within this nebula. Near the hand's fingertips lies a red cloud called RCW89, which is believed to be heated by pulsar winds, producing a soft X-ray glow. NuSTAR observed energies in this region ranging from 7 to 25 keV, while Chandra recorded levels between 0.5 and 2 keV. Studying such formations deepens our understanding of star life cycles and the phenomena following a supernova, offering insight into how pulsars interact with their environment. distributing energy and matter into space. As technology advances, enabling us to observe the universe in different wavelengths, we'll continue to uncover more remarkable formations that reveal the forces shaping our cosmos. Mars, often called the Red Planet, has long fascinated scientists and space enthusiasts. Recent studies have revealed compelling evidence that Mars once had a much more hospitable environment, potentially capable of supporting life. The planet's southern highlands, particularly near the Hellas Basin and around Huygens Crater, display intricate networks of valleys. These formations strongly suggest the presence of flowing water in Mars's distant past, approximately 3.5 to 4 billion years ago. The valley systems bear a striking resemblance to river networks on Earth, such as the Yangtze River, indicating a similar formation process. Geological evidence points to water flow from north to south, carving out impressive valleys up to 2 kilometers wide and 200 meters deep. Over time, these valleys have eroded, but their remnants still tell the story of Mars's watery history. The scale and distribution of these features suggest that Mars once had a much thicker atmosphere, capable of maintaining liquid water on its surface for extended periods. The presence of water is crucial for life as we know it, making these findings particularly exciting for astrobiologists. While the current Martian surface is inhospitable with its thin atmosphere and extreme cold, the planet's past conditions may have been conducive to microbial life. Various sources likely contributed to Mars's ancient water systems. Besides possible rainfall and rivers, scientists speculate that groundwater and melting glaciers may have played significant roles in shaping the Martian landscape. To further investigate Mars' potential for past or present life, space agencies are planning ambitious missions. The ExoMars mission, a collaboration between the European Space Agency and Roscosmos, aims to send a rover to Mars to search for signs of life beneath the surface. This mission will be complemented by the ExoMars Trace Gas Orbiter, which will study the Martian atmosphere from above. These missions are part of a broader strategy to explore Mars comprehensively, with future plans potentially including bringing Martian samples back to Earth for detailed analysis, a feat that would significantly advance our understanding of the planet's history and potential for life. The study of Mars's watery past is not just about understanding one planet. It provides valuable insights into planetary evolution and the conditions necessary for life to emerge and thrive. By comparing Mars's history with Earth, scientists can better understand the factors that make a planet habitable and how these conditions can change over time. The ExoMars mission, a joint effort by the European Space Agency and Roscosmos, aims to deploy a rover on Mars to search for evidence of life beneath its surface. Accompanying this mission is the ExoMars Trace Gas Orbiter, which will analyze the Martian atmosphere from orbit. These initiatives are part of a larger plan to thoroughly investigate Mars, with potential future missions focused on returning Martian samples to Earth for in-depth study, an achievement that would greatly enhance our knowledge of the planet's history and its capacity to support life. Studying Mars's watery past offers more than just insights into one planet. It sheds light on planetary development and the conditions needed for life to arise and flourish. By comparing Mars's evolution to Earth's, scientists can gain a deeper understanding of what makes a planet habitable and how those conditions can shift over time. NASA scientists have made a groundbreaking discovery on Uranus, observing a polar cyclone at its north pole for the first time. This finding adds Uranus to the list of planets in our solar system known to have such atmospheric features, furthering our understanding of planetary weather patterns. The discovery was made through the analysis of radio waves emitted by the planet, allowing scientists to detect atmospheric characteristics that are not visible through traditional optical observations. The polar cyclone on Uranus is characterized by a warm, dry core that remains stationary at the pole, unlike Earth's hurricanes, which move across oceans. Uranus, the seventh planet from the Sun, is known for its tilted axis, which causes extreme seasonal changes. Its 84-year orbit around the Sun means that its poles are exposed to sunlight for decades at a time, followed by equally long periods of darkness. This unique orbital characteristic makes the observation of its poles particularly interesting to scientists. The Very Large Array in New Mexico played a crucial role in this discovery, with observations made in 2015, 2021, and 2022 revealing that Uranus's North Pole was warmer and drier than expected, indicating the presence of a large cyclone. This discovery challenges previous assumptions about Uranus's atmosphere and emphasizes the dynamic nature of gas giant planets. Comparisons have been made between this cyclone and similar features observed on Saturn during NASA's Cassini mission, offering valuable insights into the formation and behavior of storms across different planets. One of the most fascinating aspects of this finding is the cyclone stability. Unlike hurricanes on Earth, which fade after landfall, the polar cyclone on Uranus appears to be a long-lasting feature. This raises intriguing questions about the energy sources and atmospheric dynamics that sustain such massive storms on gas giants. The timing of this discovery is particularly fortunate, as Uranus's current orbital position allows Earth-based telescopes to clearly observe its poles for the first time in decades. This alignment offers a rare chance for scientists to study these regions in detail. The new data on Uranus's atmosphere enhances our understanding of planetary science by helping scientists develop more comprehensive models of atmospheric processes across different planets. The discovery of the polar cyclone on Uranus opens up new avenues for research. Future studies may focus on understanding the cyclone's internal structure, its interaction with Uranus's magnetic field, and its role in the planet's overall atmospheric circulation. As our technology and observational techniques continue to improve, we can expect more discoveries that not only enhance our knowledge of these distant worlds, but also provide valuable insights into the diversity and complexity of planetary systems. In general, decoding the sun's mysterious heartbeat signals has led to a significant breakthrough in understanding mysterious signals emanating from the sun during solar flares. These signals, known as quasi-periodic pulsations, QPPs, resemble heartbeats when graphed and could revolutionize our comprehension of solar storms. Solar flares are intense bursts of radiation from the sun's surface that release various types of energy, including radio waves, microwaves, and ultraviolet light. These flares are often accompanied by coronal mass ejections, CMEs, massive eruptions of solar material into space. Researchers have long been puzzled by QPPs, struggling to understand their origin and importance. However, a study published in Nature Communications on December 12, 2022, provided new insights into these mysterious pulses. By analyzing data from a medium C-class flare on July 13, 2017, the research team discovered two distinct pulsation patterns. The primary pulse, occurring every 10 to 20 seconds, was traced to the base of the current sheet, where magnetic field lines break and reconnect during a solar flare. A secondary, softer pulse, with a 30 to 60-second interval, was observed across the entire current sheet. This finding challenges existing theories on solar flare dynamics and energy release mechanisms. The researchers suggest that both pulse patterns likely arise from the formation of magnetic islands within the current sheet, regions where magnetic field lines twist and reconnect, playing a key role in the energy release process during solar flares. Understanding these pulsations is key to predicting and potentially mitigating the effects of solar storms on Earth. Solar flares and CMEs can disrupt satellite communications, affect power grids, and pose risks to astronauts in space. By decoding the sun's heartbeat, scientists may develop better early warning systems for these events. The research team's findings also open up new avenues for studying the sun's magnetic behavior. By analyzing these pulses, scientists can gain insights into the complex processes occurring in the sun's atmosphere during flares, which are difficult to observe directly due to the intense heat and radiation involved. Moreover, this discovery may have implications for our understanding of other stars. If similar pulsations can be detected in distant stars, it could provide valuable information about their flare activity and magnetic properties. The study of QPPs emphasizes the significance of long-term solar observation programs. Detecting and analyzing these subtle signals requires continuous, high-resolution monitoring of the sun across various wavelengths. As solar activity intensifies toward the peak of the current solar cycle, anticipated around 2025, these insights will be vital for predicting and comprehending solar weather events. The sun's cosmic pulses may provide crucial clues to unraveling the mysteries of its behavior and its effects on our technological society. The pillars of creation, found at the core of the Eagle Nebula, M16, are among the most famous and mesmerizing formations captured by the Hubble Space Telescope. These towering clouds of gas and cosmic dust have fascinated both scientists and the general public since they were first observed. Stretching around 4 to 5 light years in length, they represent just a small portion of the much larger Eagle Nebula, which spans about 70 by 55 light years. The nebula itself, discovered in 1745 by Swiss astronomer Jean-Philippe Loys de Chasseaux, is located roughly 7,000 light-years away in the constellation Serpens. The pillars of creation are more than just a visually striking formation. They serve as an active stellar nursery. New stars are forming within these dense clouds of gas and dust, hidden from direct view. The star formation process within these pillars provides astronomers with valuable insights into the life cycle of stars and the evolution of galaxies. The colors visible in Hubble's image of the pillars are not just for aesthetic appeal. They convey important scientific information. The bright blue areas indicate the presence of oxygen, while the rich reds represent sulfur, and the vibrant greens are a combination of both nitrogen and hydrogen. These color variations help astronomers understand the chemical composition and physical conditions within the nebula. One of the most intriguing features of the pillars of creation is their ever-changing nature. Constantly sculpted and eroded by the intense ultraviolet radiation from nearby young, hot stars, this process, called photoevaporation, gradually reshapes the pillars, potentially revealing the stars forming within them. The most detailed image of the pillars to date was taken by Hubble in 2014, offering an unprecedented view of this cosmic structure. With enhanced clarity, scientists can now examine the intricate formations within the pillars, shedding light on star formation and how stellar radiation interacts with interstellar material. Observing the pillars of creation from Earth requires specific conditions and equipment. While the Eagle Nebula can be spotted with a small telescope, especially in July when conditions are ideal, the pillars themselves are only visible through larger, more powerful telescopes. The study of the pillars of creation extends beyond just understanding this particular structure. It provides crucial data for modeling star formation processes throughout the universe. By observing how stars form and interact with their surrounding environment in the pillars, astronomers can better understand similar processes occurring in distant galaxies. As our observational capabilities continue to improve, structures like the pillars of creation will likely reveal even more secrets about the cosmic processes that shape our universe. They stand as a testament to the ongoing drama of stellar birth and death playing out across the cosmos, offering a glimpse into the dynamic and ever-changing nature of our galaxy. Messier 87, or M87, is an extraordinary elliptical galaxy recognized as a true cosmic giant. Situated around 54 million light-years away in the Virgo constellation, M87 is a key member of the Virgo cluster, which contains roughly 2,000 galaxies. What truly distinguishes M87 is its immense size and unique features. Unlike our Milky Way, with its several hundred billion stars, M87 contains trillions of stars, making it one of the largest galaxies in the nearby universe. At its core lies a supermassive black hole, which gained worldwide attention in 2019 when the Event Horizon Telescope captured the first-ever image of a black hole shadow. This black hole is estimated to have a mass of 6.5 billion times that of our Sun, making it one of the most massive black holes known. Another distinguishing feature of M87 is its unusually large population of globular clusters. While our Milky Way has about 150 of these ancient spherical collections of stars, M87 hosts an astounding 15,000 globular clusters. This wealth of globular clusters provides astronomers with valuable information about the galaxy's formation history and evolution. M87's unique characteristics extend beyond its core. One of its most striking features is a relativistic jet of plasma that extends from the galaxy's center. This jet, visible in multiple wavelengths of light, stretches for thousands of light years and is propelled by the energy from the central black hole. The jet's blue color in visible light images is due to synchrotron radiation produced by electrons moving at nearly the speed of light. M87's location at the center of the Virgo cluster has likely played a significant role in shaping its development. Researchers believe that this galaxy has expanded over time by absorbing smaller ones, which may explain its vast size and large number of globular clusters. Originally discovered by Charles Messier in 1781, M87 remains a focus of ongoing research. With an apparent magnitude of 9.6, it can be seen with a small telescope under favorable conditions, especially in May, when viewing is ideal. Recent Hubble Space Telescope observations have captured stunning visible and infrared images, showcasing M87's elliptical form and the striking jet extending from its core. These new details offer astronomers valuable insights into the structure and behavior of this massive galaxy. Studying M87 is essential for understanding how large galaxies form and evolve, how supermassive black holes behave, and how galaxy clusters operate. As our observational tools and techniques improve, M87 will continue to unveil new mysteries about the universe and the extreme environments within it. NASA's Curiosity rover, launched in 2011, has been exploring Mars's Gale crater since 2012, providing invaluable insights into the red planet's past. Under the leadership of project scientist Ashwin Vasavada, the mission is focused on unraveling the mysteries of this particular Martian region. Gale crater, formed about 3.5 billion years ago, offers a unique window into Mars' geological history. The primary question driving Curiosity's mission is whether this area could have supported microbial life in the distant past. During this period, Mars likely had a much thicker atmosphere and abundant liquid water, creating conditions potentially favorable for life. Curiosity's mission goes beyond searching for actual life forms. Instead, it aims to identify the basic requirements that would have made life possible. These include the presence of liquid water, carbon, and other essential chemical elements, as well as potential energy sources that primitive microorganisms could have utilized. In its inaugural year, the Curiosity rover made a groundbreaking discovery at Yellowknife Bay. This site unveiled signs of an ancient lake bed, offering vital insights into Mars' historical environment. Chemical analyses revealed that the area was neither overly acidic nor excessively salty, indicating it may have been habitable for microbial life. Further studies identified essential life-supporting elements like carbon, nitrogen, sulfur, and phosphorus. Moreover, Curiosity detected potential energy sources that could have fueled microbial metabolism. These discoveries collectively imply that ancient Mars, particularly within the Gale crater region, may have had conditions conducive to supporting early life forms. The rover's capacity to analyze the chemical composition of Martian rocks and soil has been instrumental in unraveling the planet's environmental history. Kepler 186f, identified by NASA's Kepler Space Telescope, was the first Earth-sized exoplanet found within the habitable zone of its star. Situated approximately 500 light-years away in the Cygnus constellation, Kepler 186f orbits an M-dwarf star. This pivotal discovery represents a major advancement in the quest for potentially life-supporting planets beyond our solar system. Kepler 186f is especially intriguing due to its position within the star's habitable zone, where conditions could support the presence of liquid water on its surface, a crucial factor for life as we know it. Although Kepler 186f's exact composition and mass remain uncertain, it is believed to have a rocky surface. This finding underscores the potential for Earth-sized planets in habitable zones around other stars, enhancing hopes of discovering more worlds that could support life. Titan, Saturn's largest moon, boasts a distinctive hydrological cycle. Unlike Earth, Titan's lakes and seas are filled with liquid methane and ethane rather than water. NASA's Cassini spacecraft, which orbited Titan from 2004 to 2017, delivered groundbreaking insights into the moon's surface. A major breakthrough came in 2007 with the discovery of these liquid bodies, making Titan the only other world known to have stable liquid on its surface besides Earth. Recent research has unveiled intriguing details about Titan's lake systems. In the moon's northern hemisphere, deep lakes are found on hills and mesas, mainly composed of methane. This is different from the mixed methane-ethane composition seen in Titan's larger seas and the southern hemisphere's Ontario Lacus. The distribution of these liquid features is uneven. The eastern northern hemisphere contains the largest seas, while the western side features smaller, deep lakes on elevated terrains, some reaching depths over 300 feet. Scientists suggest these lakes might have formed similarly to Earth's karstic lakes, where surrounding bedrock dissolves and collapses. On Titan, this would involve the chemical dissolution of ice in organic bedrock by liquid methane, leading to depressions that subsequently fill with liquid. One of the most fascinating features of Titan's hydrological system is its transient lakes. These liquid bodies seem to experience seasonal fluctuations in their levels, likely due to processes like evaporation or seepage into the subsurface. This indicates a complete methane-ethane cycle on Titan, similar to Earth's water cycle. Given Titan's surface temperature, water is frozen solid, while methane and ethane behave like water on Earth, existing in liquid, solid, and gaseous forms. Studying Titan's lakes and seas is not just intriguing, but crucial for understanding the potential for life in extreme environments. Although life, as we know it, cannot survive in Titan's methane lakes, the presence of complex organic chemistry and energy sources opens up fascinating possibilities for alternative forms of life. Upcoming missions to Titan, including NASA's Dragonfly mission set to launch in 2026, are designed to delve deeper into this enigmatic world. These missions aim to clarify the lake's composition, depth variations, and seasonal changes. Investigating Titan's methane cycle could also shed light on Earth's early history and the conditions needed for life to develop. By exploring this alien yet somewhat familiar world, scientists hope to broaden our understanding of planetary environments and the potential for life beyond Earth. Thank you for watching another episode of Just Discovery. If you enjoyed this video, please like, subscribe, and hit the notification bell for updates on more exciting content. See you next time.